the search for exoplanets beyond our solar system has led to remarkable discoveries in the field of astronomy. With over 5,000 exoplanets detected so far, scientists estimate that, on average, there is at least one planet per star in our galaxy. Among these discoveries, the study of red giant stars has emerged as a fascinating frontier. These aging stars, like our Sun in its later stages, undergo significant transformations, expanding to sizes hundreds of times larger than their original form. Today, we delve into the intriguing case of Baekdu, a red giant star that defies expectations, and the surviving planet that orbits it, Planet Halla. Their mission was to investigate the survival of planets around red giant stars, particularly those that have already initiated the fusion of helium in their cores. The discovery of Halla orbiting Baekdu caught their attention, a planet that, based on their understanding, should have succumbed to the star's expansion. To unlock the secrets behind this celestial enigma, the international team of astronomers harnessed the power of NASA's Transiting Exoplanet Survey Satellite, TESS. Utilizing the techniques of astroseismology, the study of waves within stars, they probed the internal waves of Baekdu to discern its fusion activity. The frequencies of the waves unambiguously revealed that Baekdu had indeed initiated helium burning. However, this revelation posed a puzzling question: how did Halla survive the star's expansion when conventional wisdom suggested its engulfment? To eliminate the possibility of Halla being an illusion, the team conducted extensive observations and analyses. They meticulously monitored Baekdu's Doppler signal over a span of 13 years, ruling out any fluctuations that could have indicated a false positive. The signal remained stable, providing further evidence of Halla's existence. After dismissing the notion of Halla's illusory existence, two plausible scenarios emerged to explain its survival. One possibility is that Baekdu was once part of a binary star system. If this hypothesis holds true, the merger of the two stars may have impeded Baekdu's expansion, thus averting the engulfment of Halla. Alternatively, Halla could be a nascent planet, born from the remnants of a cataclysmic collision between two stars. The violent collision may have produced a cloud of gas and dust, from which Halla formed. In essence, it would be a second-generation planet. Irrespective of the explanation, the discovery of Halla challenges our preconceived notions about the range of exoplanet habitats. Nature has an uncanny knack for defying our expectations. It unveils planets in the most unlikely places, including the vicinity of helium-burning red giant stars. As we gaze into the cosmos, let the enigmatic tale of Planet Halla serve as a humbling reminder of the limitless wonders that await our exploration and comprehension. The story of Halla, the planet that eluded its star's fiery fate, continues to captivate scientists, propelling us further into the depths of knowledge as we strive to unravel the mysteries of the universe. The existence of Halla challenges our understanding of planetary survival in extreme stellar environments. It raises intriguing questions about the potential habitability of planets orbiting red giant stars. Their findings emphasize the need to expand our search for exoplanets beyond the traditional habitable zones around main sequence stars. It's possible that there are other unexpected oases of life waiting to be discovered. The tale of Halla reminds us that the cosmos is a dynamic and ever-evolving place, where the interplay between stars and planets can give rise to astonishing phenomena. It urges us to remain curious, to push the boundaries of our knowledge, and to embrace the surprises that await us in the vast expanse of the universe. As we continue our quest to understand the mysteries of the cosmos, we are humbled by the resilience of planets like Halla, standing defiantly against the tidal forces of their aging host stars.